Welcome back, everybody. I'm Dave, and today we are going to go through the quotient rule, which is part of the differential calculus unit. Okay, so the formula for the quotient rule is given on the left. So I'll just show you or explain what's happening here, that if we have a quotient and we have the denominator in terms of v of x, and the numerator in terms of u of x, then what we'll need to do is take v and multiply it by du by dx, and then also take u and times it by dv by dx. And what we'll do is there is a subtraction or a minus in between those two terms, and that will all be divided by v squared. So v du minus u dv all over v squared. And this will be given in the formula booklet if you're IB. Otherwise, you will need to remember it if you're in another course. So let's go ahead and look at the first question that we have here, part A. Use the quotient rule to find dy by dx if y is equal to 1 plus 3x over x squared plus 1. So when you see this in an exam question, what you'll see straight away is that there is a fraction involved, and it is in terms of y and x. So we have 1 plus 3x here over x squared plus 1. Okay, and what you'll do is you'll recognize that you'll need to label the top as u, 1 plus 3x, and the bottom as v, so the denominator as v x squared plus 1. Okay, so looking back at the quotient rule, remember that I will need to take u and v and multiply it by their counterparts, basically the other expression, but the derivative of that expression. So let's go over to here now, and u is equal to 1 plus 3x, so u prime, or du by dx, if you prefer that notation, would just be like 3. V prime would just be 2x. So now I have all parts to put into the quotient rule formula, so I'll just go over to the right-hand side here. Quotient rule states that to find dy by dx, so y prime, we can find it by doing v du, so v times the derivative of u, minus u times the derivative of v, all over v squared. So all of those expressions are given here that I've just circled in white. Let's put them in. So v was x squared plus 1. Du by dx was just simply 3 minus u. Now, important to remember, keep u contained within the brackets because it is 1 plus 3x, so we want to keep it all together, times by the derivative of v, and that is simply 2x there from the left. And that is all divided by v squared. So v squared is x squared plus 1 all squared. And that is the derivative of y with respect to x. So if we just simply had to just leave the question there, then we are done. You can multiply out and you can group terms together, but at this stage, I'm not going to do that. It doesn't ask me to get it in any particular form, so I would just leave that as y prime is equal to this. Now, what I would do, though, is not leave it there, because in the question it does say, hence finding the gradient when x is equal to 1. So therefore, I'm going to just go ahead and substitute 1 into this expression, because I want to know what the gradient is at x is equal to 1. So this will be the final stages of part A, whereby we want to substitute 1 into this. So we will have 1 plus 1, which is 2, 2 times 3, minus, and it will be 4 times 2 here, all over 2 squared. Okay, so I've just substituted x is equal to 1 into this. And that will come out to be 6 minus 8 all over 4. So therefore minus 2 over 4, which is equal to minus half. And therefore then I can confirm now that the gradient when x is equal to 1 is negative 1/2.
Oh, I love it. Great stuff.
Okay, so let's have a look at question B. We have another function of y equaling root x over 1 minus 2x all squared. So, and we have to find the gradient at x equals 1 again. So this time I'm going to just define the numerator as u and that is root x. But remember, in order to proceed with this, we'll want to write that as an indices, so we can use the power rule on this. The derivative of u with respect to x will be half x to the minus half, okay? Now, v, in this instance, will be the denominator, and that will be 1 minus 2x all squared. Now, we're building on the previous part of the course where we'll need to use chain rule now in order to differentiate this. So v prime is times by the power. Remember the quick method I showed you. Take one off the power, so everything in the bracket stays the same there. Okay, times by the derivative of the bracket, which is -2. So if we just tidy that up a little bit, we'll have -4, open brackets, 1 minus 2x. And because this is relatively easy to multiply out, I can do that. If there was still a power left on the bracket here, I probably wouldn't, because there's no need if we're going to substitute 1 into it. But because it's a relatively easy expansion, I'll get -4 plus 8x. Okay, so that is v prime. Now what I'm going to do is I'm just going to sort of circle these, okay, so you can see them a little bit clearer, okay, because these are going to be my substitutions into the quotient rule. Okay, so let's go ahead and start plugging this in. So we have what dy by dx is defined by taking v du minus u dv over v squared. Okay, that's a quick way of writing the quotient rule. It's v times the derivative of u over x minus u times the derivative of v over x all over v squared. Let's substitute in v, which is 1 minus 2x all squared, times the derivative of u, which is half. Now, just want to sort of draw your attention to this here, is x to the minus half. So whenever we see a negative, it's like the reciprocal, so it's 1 divided by, and then it's x to the half. So it'd be 1. So this will become half times 1 over root x. Now that's going to be important when I substitute the value in a moment, which will be 1. So I'm going to just write that down there. That is 1 over root x. Okay. Subtract u, which is x to the half, which is root x. Sort of zoom out there so you can see that, times that by the derivative of v, which was the -4 plus 8x. Okay, so that's the -4 plus 8x. There, sorry, plus. And that is all divided by v squared. So v squared was 1 minus 2x squared, all squared. Okay, and that's an interesting point there, that is going to be a rule of indices there, that when you have a power raised to another power, you will actually multiply those powers together. So that will become to the power 4. It's important that you don't add them, you are multiplying them together. So now we are ready to substitute in our value, because the question stated at the point, we need to find the gradient at the point where x is equal to 1. So we're going to substitute 1 into all of this. Now it looks complicated, but 1 is quite a nice number to plug in, so it shouldn't be too complicated. So we have 1 minus 2. So I'm just substituting 1 in for all of these x's. So 1 minus 2 is -1. -1 squared will just be 1. Times by a half. 1 over root 1 is just 1. Minus root 1, which is just 1, times by -4 plus 8, which will be 4. And all of this is divided by, so be careful here, it's 1 minus 2 times 1, so it's -1 to the power 4. Now, -1 to the power 4, okay, will be positive 1. -1 times -1 times -1, and so on. So this will just be positive 1. So I'll just delete that there and put this 1. So just tidy this last little bit up then. So we've got 1 times 1 times a half, so it's a half, subtract 4, okay, over 1. Now we don't really need the divide by 1, because anything divided by 1 is just itself, so it's just a half minus 4, which would be just minus 3.5, 0.5, or 7 over 2. Okay, that's it. Good luck with your quotient rule questions. Don't forget to like and subscribe to the channel to see more math tutorials. Check out my playlists on my channel or click one of the videos above. I'll see you next time.